In this unit, we're going to look at calculating sample size for problems involving proportions. So recall the following terms that we've talked about: population distribution, and that would be the frequency distribution of all the elements of a population. A sample distribution, so the frequency distribution of all the elements in an individual sample, and the sampling distribution of the sample mean, which is the frequency distribution of the means of many samples from a given population. So those concepts and the central limit theorem help us figure out how to calculate the sample size that we might need, anticipating a certain level of variability that we're going to end up with, that we're going to need to take account of when we do our inferential statistics. So for proportions, we need three pieces of information. We need an estimate of the population variation. We need to know the acceptable margin of error. And remember, margin of error is everything after the plus minus in a confidence interval. And we need the desired level of confidence, that the sample will fall within a certain range. That's a z-value, and usually our level of confidence is 95%. So for proportions, the margin of error is z times the square root of the proportion times 1 minus the proportion over n. And if we use some algebra on this, what we have is n is equal to the z squared times the proportion times 1 minus the proportion all over the error squared. And if we don't have an estimate for p, the most conservative thing to use is 0.5. And you can sort of try that out with some different combinations, but that's the one that will give you the largest potential sample size, which is the most conservative. So here's an example. Assume that previous fast food research has shown that 80% of consumers like curly French fries. The researcher wishes to have a margin of error of 6%, which is 0.06, or less, and be 95% confident of an estimate to be made about curly French fry consumption from a survey. What sample size should be used in a simple random sample? So the margin of error that we want is 0.06 E. The proportion that we have from the past is 0.80, 80%, and at 95% confidence, Z is 1.96. So what is N in this case? N is equal to Z squared, which is 1.96 squared, times P, which is 0.80, times 1 minus P, so 1 minus 0.80 or 0.20, all over E squared, which is 0.06 squared. And if you work that all out, you're going to end up with something like 171. And here it is on the next page. Notice that it comes out to 170.67. And the rule for sample size is always round up. Always round up. I hardly ever say always, so you know this is a big one. And that is to ensure that you have sufficient sample size to accomplish what you set out to accomplish. Quite honestly, in many cases, we round up to some kind of whole number. So we might round this to 175 or 180 or even 200. But technically, you should at least round up to the next whole number. Now, what if we didn't have the 80% from previous studies? Then we would want to use 0.50 as the conservative estimate. And so then we would have n is equal to 1.96 squared times 0.5 times 1 minus 0.5. And notice that's what changes, is the p and 1 minus p over 0.06 squared. And that works out to 266.78, which we would round up to at least 267. Okay, so notice last time it was 171 with this, with less information. so more uncertainty. So taking the conservative route, it goes up quite a bit to 267. That's it for proportions.